So you can rewrite a function as a Taylor polynomial. And so to do that, well, specifically they want a second Taylor polynomial. So that just means they want us to stop here with the second derivative. And then a is just where you're centering your Taylor series around. In this case, we're plugging pi in for a. That's it. That's all we really have to do. It's just plugging in things into this notation. So x equals pi, I plug in pi in for x, and that's my f of a. Now the first derivative, the derivative sign is cosine. And it's x minus pi here. Oh, sorry, that's big distinction. This is cosine pi. That's function notation. And then mathematicians with their terrible notation, another parentheses next to it actually isn't function notation. The parentheses this time mean multiplication. So pretty crazy. And then the second derivative would be the derivative of this term. So that's going to be negative sign. And that's at the center of pi divided by 2 factorial, which is, in case you need a refresher, 3 factorial is just 3 times 2 times 1. Okay. And then over here, this is x minus that center pi squared. That's it. We just need to simplify it. Sine of pi is 180 degrees. Sine is the y coordinates on the unit circle. This is 0 comma, this is negative 1 comma 0. So sine is 0 at pi. Cosine of pi would be negative 1. And then x minus pi just goes here. Then sine of pi, we already said that's 0, so this term is going to be 0. And okay. Then we can finish simplifying here. Negative x plus pi. And they wanted to estimate sine of 1 plus pi. So what the Taylor series does is it can give you better and better, depending on how far you bring the series, better and better approximations of a certain value. So we centered ours at pi. They want us to use this approximation at pi at plus 1 to pi. So what you're actually doing is you're plugging in 1 in for, you're plugging in that approximation 1 plus pi in for x here. So if you do that, so that's going to give us negative 1, because this is negative 1 subtracted by pi plus pi. And that's it. That was a second Taylor polynomial. So that was the second derivative. And that's all we have to do. We just have to plug that 1 plus pi into whatever expression we get after simplifying it. So this shouldn't say equals. This part right here shouldn't say equals because we just plugged it in.